In this video lesson, we are going to continue to explore arithmetic and geometric sequences and series. The first problems that we're going to talk about here are recursively defined sequences. We've been working with these before, so hopefully these problems go okay. A few things I'd like to point out before you try them on your own is problem number 2 has this exclamation mark. This exclamation mark is a factorial symbol. So what does that mean? Let's actually look at an example. 5 factorial is always the one that I like to use as my example. What 5 factorial is 5 times 4 times 3 times 2 times 1, or every integer sequentially going down from the given number. When we actually find that product, it is 120. Knowing how to find a factorial is going to make number 2 a little bit easier. And then on problem number 4, this negative exponent, rewriting that negative exponent into the denominator may make this problem a little bit easier for you to handle. So go ahead, now that I've given you these 2 hints, go ahead and pause the video and see if you can find the first 5 terms of the sequences on your paper. So go ahead and pause the video now. Okay, let's see how you did. Here are the first 5 terms of each of the sequences. The good news is the first term was given to you. Hopefully these went okay. If you are struggling, please ask a friend, ask a table member, go to the mark, or even ask me for help. We've been practicing these now for a little while, so hopefully you don't or did not run into too many issues. So for the rest of this video, we're going to focus on applications. The first application that we are going to look at is about the marching band. I like to read the problem and go ahead and gather along the side the information that I'm given. So the first thing I noticed is that the first row has 18, the second row 22, the third row 26, and I know that there are 9 rows in the marching band. I got all of this information just by reading the problem. The first question then asks, how many marchers are there in the 9th row? So this is talking about a term in the arithmetic sequence. How do I know that this sequence is arithmetic? Well, going from term to term, from 18 to 22, 22 to 26, there's a constant difference there, or common difference. So I know that this is arithmetic. So the first thing I want to do is I'm going to want to write out the generic arithmetic term here. So I know my first term is 18 and that common difference is 4. Now in word problems, there are restrictions on our domain or on our n values. And for this particular problem, that domain restriction is from 1 to 9. I know that there are only 9 rows in the marching band and there can't be less than 1 row. So this sequence only applies for n values between 1 and 9. Since the question is asking for the 9th row, I'm going to go ahead and plug in n equals 9 and simplify that down to figure out that there are 42 marchers in that 9th row. Now the second question is asking about total or a series or sum. So I'm going to need to write the arithmetic series that represents this particular problem. And that series looks like this. When you evaluate that, you can figure out that there are 306 total marchers in this marching band. Our next problem here is going to talk about salary and a basic exponential growth problem. The question is asking, what will your annual salary be during your 10th year with the PGA Tour, or the 10th value in this sequence? So we're going to need to write out an arithmetic or a sequence, when we're talking about a 5% raise per year, that is a geometric problem. It's an exponential growth problem. So our sequence here is going to be a geometric sequence. And that sequence looks like this. The 45,000, that's right here. That comes from our starting salary. We know it's a growth problem because the salary is increasing. That's why we have a plus sign. 5% is 0.05, and it is raised to the n-1 power. Now, why is it not raised to the nth power? You might be wondering. Well, that's because the $45,000 is the first year, and you only receive increases in your salary after year 1, so it's not to the nth power, but to the n-1 power. When we go ahead and plug in 10, because they want to know the 10th year's salary. It looks like this, and then you can type that into your calculator to figure out that you would earn almost $70,000 the 10th year on the PGA Tour. So our next problem is about tulips. This particular problem is very similar to the marching band problem. If you're feeling ambitious, go ahead and pause the video now and see if you can figure this out. If you need to be walked through it, that's fine too. Remember, our very first step is to gather the information that we know. So we know that the first row contains 20 tulips, the second row contains 26, the third row contains 32, and there are 8 total rows, or n equals 8. Our first question is asking how many tulips are there in the 8th row. So we are looking for a sequence. We need to figure out, is this arithmetic or geometric? Now, looking at the problems, am I going up by a common difference, or am I going up by a common ratio? Now, for this particular problem, we are going from term to term up by 6, by adding 6 each time. So this is a common difference. Therefore, this is an arithmetic problem. So our arithmetic sequence is going to look like this, 20 being our first term and 6 being our common difference. When we plug in n equals 8, we can figure out that there are 62 tulips in row 8. Now, the second question asks how many tulips are there altogether, or a series question. What does that arithmetic series look like? The arithmetic series looks like this, and when we evaluate it, we can figure out that there are 328 total tulips. So hopefully that problem went okay. Like I said, this problem was very similar to the marching band problem. One more problem to go here, and this problem is about investments. A very real life problem here. The very first thing that we need to do is we need to realize that this problem talks about 2 different time frames. We know that there is a deposit made, $50 every month, and then they mention over here 2 years. So we're going to need to convert that years into months, and by multiplying 2 and 12, we can figure out that 2 years is in fact 24 months. Now, hopefully you remember the compound interest formula that we talked about earlier in this chapter. That particular unit, or that particular formula, is going to be used here because we're talking about compound interest. So let's write out what a few of these months would look like. So month number 1 looks like this. The $50 is our initial investment, and then we know that it is going to earn the 0.03 or 3%. It is being compounded 12 times per year, and it is raised to the n times t, or the 12 times 2. Now, if you were to try to evaluate this number is too big for your calculator to actually evaluate. The money that you put in month 1 is going to be the money that's going to grow the most because it is in there for the longest amount of time. So now let's take a peek at what the money would look like at month 2. You can see here that I changed or simplified it a little bit. Instead of being 1 plus 0.03 over 12, I simplified that down to be 1.0025. It's just to make this process a little bit easier. And now this is going to be in the account for 23 months, whereas the very first month is going to be in there for 24 months. Month 3 is going to look very similar. Now we're just raised to the 22nd power. So let's bring this down now to the very end. Month 24, what does that look like? On the 24th month, it is only going to spend 1 month in the investment account. So that's why it is raised to the first power. And this particular value we can calculate on our calculator. When we type this into our calculator, we realize that month 1 is going to grow or be 50.125 in the account. So now what's this question asking? What will the balance be in the money market account 2 years from the day of the initial deposit? So they want to know the total or the sum of all of these values here. So we're talking series, but is this arithmetic or geometric? Take a look. Are we adding each time, common difference, or are we multiplying each time? These parentheses hopefully are a giveaway here to tell you that we are in fact multiplying, therefore this is a geometric series. So let's go ahead and gather what we need in order to be able to find the sum of this particular problem. We know that a sub 1 is that 50.125. We know that our r is 1.0025. You notice that that is what's in parentheses for each term. And we know that it's going to be for a total of 24 months, therefore n equals 24. When we plugged into the geometric series formula, we get this particular problem, and then carefully typing this into our calculator, we can figure out that after the 2 years, making a $50 a month deposit, that money now is all of a sudden $1,238.23. So making a small investment on a month-to-month basis really does pay off, because all of a sudden your $50 per month has definitely paid off. So I hope these problems went well for you. Do not be afraid to help each other, to explain things to each other. When you have completed your note sheet, please show it to the sub, and the sub will get you your homework for tonight.